Hello everyone, thank you for watching my video. And in this video today we're going to do a lot of review from things that you hopefully have learned in the past about polar coordinates. Alright, so let's just start with the polar coordinate system. The polar coordinate system is a little different than a rectangular coordinate system in that it's not a rectangle, it's a circle. Okay, the center isn't called the origin anymore, it's called the pole. Okay, and this is called the polar axis here. To plot points here, the points are given as r comma theta, but honestly what I usually do is I usually do theta first and then do r from there, but you can do it either way. Basically, you want to go r units out at an angle of theta. So if I got a point that was 30 degrees, I would go to 30 first, and then I would go r units out from there. Okay? Suppose r is greater than 0, then theta would be the measure of any angle in standard position that has ray OP as its terminal side. But if r is less than 0, we would basically go the opposite way. We would go the opposite way from theta. Okay, so r could be positive, could be negative. If r is positive, we go towards theta. If r is negative, we go away from theta. So let's start with a couple quick examples. To plot a point, so negative 1.5 comma 7 pi over 6. So again, I usually do thetas first. 7 pi over 6 would be this angle right there. Okay. And then negative 1.5 means we're going to go away from it. So again, 7 pi over 6 would be this angle, but that means we're looking at this whole line right there. Negative 1.5 means we're going to go away from this. So towards this 1.5 units, and that would be right about there. So that would be the point negative 1.5 comma 7 pi over 6. All right, negative pi over 3, 2. So 2 negative pi over 3. So negative pi over 3 would be this line right here. And if we're going 2 towards that, it would be right there. Converting back and forth. Converting from polar to rectangular, we use the functions x equals r cosine theta and y equals r sine theta. Those are usually pretty easy. Converting from rectangular to polar, we use these two equations here, which is basically the Pythagorean theorem and tangent inverse. Okay? So let's start here with converting from rectangular to polar. Using these formulas up top here, so x equals r cosine theta, y equals r sine theta. So it would be root 3, cosine of pi over 6 is root 3 over 2. Root 3, sine times pi over 6, sine of pi over 6, sorry, is 1/2. So then my point would be root 3 times root 3, which is 3 halves. Root 3 times 1, which is root 3 halves. Convert one from polar to rectangular coordinates. Oh, this is actually supposed to say polar coordinates again. Oh, sorry, from polar to rectangular. I was reading that right, okay. So from rectangular to polar. So for this, what I like to do is draw a quick sketch, nothing too crazy, just plot the point about where it would be right about here, okay? And draw a right triangle in from that. Point's negative 1, 1. So the easiest way to do the thetas here is to recognize, is this a 30, 60, 90, or a 45, 45, 90? And the answer is it's a 45, 45, 90, which means this would be 135. This would be root 2. So my answer would be root 2 comma 135. If you want it in radians, root 2 comma 3 pi over 4. All right, so next slide, there are 4 problems, 2 of each. If you'd like to try these on your own at this point, please feel free to do that. Pause the video here and come back when you're ready. Otherwise, you can stick with it right now and we'll go through them. All right, so we're going to do r cosine theta, comma, r sine theta. All right, and that would be equal to 2 root 3 times root 3 over 2, comma, 2 root 3 times 1/2, which simplifies down to 3, comma, root 3. For b, 8 cosine pi over 4, comma, 8 sine pi over 4. So that's 8 times root 2 over 2, comma, 8 times root 2 over 2, which is 4 root 2, comma, 4 root 2. Converting to polar. So if we start by plotting the point 3, -3, this would be 3, this would be -3, which means this is a 45, 45, 90, and this is 3 root 2. So then my answer would be 3 root 2, and my angle would be 315. If I want that in radians, 3 root 2, comma, 7 pi over 4. Or if you want it in negative radians, 3 root 2, comma, negative pi over 4. Question B, -4, 4 root 3. So that would be in the second quadrant up here. -4, 4 root 3. So this is a 30, 60, 90, with this angle being 30, this angle being 60, which means this would be 8, and this would be 150. So my answer here would be 8, comma, 150. Or in radians, 8, comma, 5 pi over 6. Okay, that's converting points, converting equations. So converting equations is very similar here. Since points can be written in both rectangular and polar format, we can also write equations in those forms. Graphs that are linear are best written in rectangular format, while graphs that have curves are best written in polar format. Non-functions with loops are very difficult to write in rectangular form and usually need to be written as a piecewise function, while in many cases are easily written in polar form. To convert from one form to another, we use the same relationships in the boxes that we did above. All right, so we're going to start by rectangular, converting to polar, and then we'll do polar, converting to rectangular. All right, so starting with A, remember y is r sine theta, so I can write this as r sine theta equals 6. And you can divide to make this r equals 6 over sine theta, and that's good enough. Or if you want to be a little bit more clean, you can write it as r equals 6 cosecant theta. All right, and if you want to graph this in your calculator, just make sure you go into polar mode, and then you can type in 6 divided by sine theta to see what that looks like. Question B, we get 4r cosine theta minus 2r sine theta minus 1 equals 0. So I'm going to factor an r out of these first two terms while moving the 1 to the other side, like that. So I would get r equals 1 over 4 cosine theta minus 2 sine theta. Can't really do much to simplify that, so we'll keep it there. Third one, we get r sine theta equals 4 r cosine theta squared. So that would be r sine theta, I'm going to bring this to the other side, minus 4 r squared cosine squared theta equals 0. Okay, if I factor out an r, which will give me, oops, I forgot r there. And if I divide through by r then, we get r equals 0, which that's just not going to do anything. That's just going to be a point at the pole. Okay. So then for the rest of it, I can move that 4r cosine squared to the other side. Divide by 4 cosine squared, I would get my final answer is r equals sine theta over r cosine squared theta. Remember, you're also going to get r equals 0 from that over there, but that doesn't really give us anything. That's just the point at the pole. Okay, and then converting from polar to rectangular. When I taught this to my pre-calc courses, I always taught them that there's usually, if you don't recognize right away what the equation would be, we can either square both sides or we can multiply both sides by r. Okay, but sometimes you don't have to do any of those things. You can just recognize from what you have. So for this first one, we have r equals negative cosecant theta. I'm going to change that into negative 1 over sine theta. All right, your goal is to get r sines and r cosines, which now we can get by multiplying sine to the other side. And remember that r sine is y, so y equals negative 1. For b, if we multiply by the denominator, I would get r sine theta plus 3r cosine theta equals 2. And then r sine is y, r cosine is x. And if you want to put this in slope-intercept form, third one. If I multiply both sides by the denominator there, I get r plus 2r cosine theta equals 3. Okay. Well, r cosine of theta, we know that's x, but r, we don't really know what that is. But remember, let's go back a couple slides here. R is root x squared plus y squared. So I get root x squared plus y squared plus 2x equals 3. Okay. For what we do for the most part, that is going to be good enough. But if you wanted to go further, we can do that. And then we can square both sides to get rid of the root. This would be 9 minus 6x plus 4x squared. And I can subtract the x squared from both sides. 9 minus 6x plus 3x squared. And if you take the square root of that, you would get y equals plus or minus root 3x squared minus 6x plus 9. Wait a minute, that's not 6. 3 times 2 is 6. There's 2 of them. So I'm sorry, that would be 12. Okay, but like I said, when I always taught this, I always said, as long as you can get rid of the r's and thetas, you're good. So this was technically back in rectangular form. But if you wanted to actually graph it and get it into a y equals form, that's the work we have to do for that. All right, so for these, what we got to do for these here is we're either going to multiply both sides by r or we're going to square both sides. That's the best way of I can explain what to do here, okay? We're trying to convert polars into parametrics. And that would be using, again, things that look like that, okay? So for this one, if r is 4, and x, remember x is r cosine theta, and y is r sine theta, that means x is just 4 cosine theta, and y is 4 cosine theta. So this is polar form, this is parametric form. And if we wanted to put it into rectangular form, which the question isn't asking, but just for practice, if we square both sides, we would get this. And r squared is x squared plus y squared equals 16. So we have all three forms here. Polar, parametric, which is what the question is actually asking us to do, and rectangular, of all the same formula. All right, for B, so since x is r cosine theta, we would have 4 sine theta cosine theta, r cosine theta. And y is 4 sine theta sine theta, or 4 sine squared of theta, r sine theta. So again, this would be parametric mode. We're not going to put that one into rectangular mode, but again, those things I'm talking about of either squaring both sides or multiplying both sides by r would be what we do. And in this one, we'd multiply both sides by r to convert to rectangular mode. For C, or x is r cosine theta, right? So x is r cosine theta, which is just 4. And y is r sine theta, which is 4 tangent theta. Okay, next on the agenda here is graphing polar equations. So we could convert these into rectangular if we wanted, or we can just figure them out on our own here. So the first one says r equals 2. That means the radius is always 2. That's just going to be a circle of all the radius 2 points. Like that. B says theta equals pi over 3. That just means that the line is always going to have the angle of pi over 3. That's the positive and negative radii at pi over 3. And for C, this is 1 over cosine, right? So that means r cosine equals 1. R cosine is x. So x equals 1. So x equals 1. That's 1, 0. It's a vertical line there. Some aren't that easy, though. Like here we have this graph. Now, hopefully you recognize from your polar days that this is going to give us a rose because of this right here. So what we can do is we can start plugging thetas in and getting answers back. If we put 0 in there, we get 3 times cosine of 0, which is 1. So 3 times 1, which is 3. So our first point would be right there. Now, I picked these values because these values are going to give us mostly some decent numbers here. That's why I picked these values. Obviously, there's more values than this on the unit circle, but these are the ones that are going to give us some nice answers back. So pi over 6, we put pi over 6 in here. We get 3 pi over 6, which is pi over 2. Cosine of pi over 2 is 0. So pi over 6 comma 0. So that point would be at the pole there. Anytime we're r is 0, we're at the pole. Pi over 4, so 3 pi over 4. 3 pi over 4, the cosine of that is negative root 2 over 2. Right, so we're at negative 3 root 2 over 2. And I'm not expecting you to know what that is, but if you want to put it in a calculator to see what you would get back, it's about negative 2.1. It's a little bit bigger than that, but negative 2.1. So at pi over 4, which is this angle here, we're at negative 2, so we're going 2 away from it. It's a little bit bigger than that. All right, pi over 3, if we put that in, we get 3 pi over 3, which is pi, so it's negative 1, so 3 times negative 1. So pi over 3, which is here, we're at negative 3, so that would be down here. Pi over 2, so 3 pi over 2, so that would be 0. 3 times 0 is 0, so we're back to the pole again. So right now we got a graph that looks like this. 2 pi over 3, so it'll be 3 times 2 pi over 3 is 2 pi. Cosine of 2 pi would be 1. 3 times 1 is 3. So at 2 pi over 3, which is right here, we're back to 3. So now we're back to here. And pi, so 3 pi. So the cosine of 3 pi would be 1. So 3 times that would be, it'd be negative 1, so that'd be negative 3. So at pi, which is here, we're back to negative 3, so we're going to go back to here. So the graph's going to go, I skipped a lot of those points, obviously, because they're not nice numbers, but the graph will look back and go through there. And that's what our rose is going to look like with 3 petals. If you don't remember, the rose, if it's odd theta, that's how many petals it has. If it's even theta, you double it to get how many petals the rose would have. And if you don't remember that, I put a summary here on the last slide of graphs of limasones, roses, circles, and lemnisates. And just some basic thoughts that we should kind of know. You're not going to be asked to actually do graphing on the AP test, but just recognizing them and then being able to derive them and find area is what you might be asked to do. Okay? So that will do it for today's look back at polar coordinates from Precalc. I hope you remember all this, and we'll get into the calculus with polars tomorrow. Thank you. Have a good day.